Okay, so these are the notes for air pollution and air quality. I think they just titled them air pollution notes in your Canvas, but you can go ahead and title them however you'd like. But we're going to just do a couple definitions to start off, and then we'll get into some types of air pollution. We're going to get into some problems with air pollution. Okay, so air quality is how clean, clear, and polluted air is. So that's it. Air quality. I mean, sure, if you look it up somewhere else, they might have a different definition, but just use our definition. It's really easy. That's why we're taking notes. So how clean, clear, and polluted air is, that's quality, okay? Air pollution. Pollution, this is chemical substances. Oh, let me get that out of the way. Chemical substances released into the air that are not normally a part of air, a large part of air. Okay, so chemical substances released into the air that are not normally a large part of air. Okay, so anything that's in the air that's not supposed to be there, that's not normally there all the time, is going to be considered air pollution. Okay, now there's lots of types of pollution, and they come in pairs that are opposite of each other. So we're going to do some bullets. Let me get a bullet here. Okay, so types of pollution. The first categorization that we can do is anthropogenic versus natural. Well, we know what natural means. Natural means caused by nature, right? So that would mean anthropogenic would be caused by people. So anthropogenic means caused by humans. Okay, and some examples could be car exhaust, which would be carbon dioxide, CO2, okay? And I'm gonna just make that small. Okay. Or factory exhaust, which could be CO, which is carbon monoxide. It could be NO2. NO2 is nitrogen dioxide. Okay, there's a lot of things that come out of factories, but those are just a couple of examples. Okay. All right, so those are anthropogenic examples. Now, natural is caused by nature. Okay, and examples of natural could be volcanoes. Okay, they're going to release a lot of stuff. CO2 is a big thing that is released by volcanoes. Or something that might be kind of silly sounding, but is actually something that is studied, would be animal farts. So if you're in ag at all, you might know that one of the attacks on raising cattle is that they create a lot of methane. So when they fart, when they gas out what they're producing, they're releasing a lot of methane. Okay, so animal farts, you can write that. Okay, the next type of categorization is outdoor versus indoor. Okay, and that one's really self-explanatory. Okay, outdoor is in the atmosphere. So outside, right? So examples again would be exhaust. Hopefully we don't have any of that inside. Methane, so animal farts again. I'm gonna put NOx. I'm gonna make that X a subscript, okay, and SOX. Okay, so NOx and SOx here, okay, but NOx and SOX are the ways that we show the sulfur oxide and nitrogen oxide compounds, because they come in more than one ratio. So that number could be different depending on what which pollutant you're talking about, but those are some examples, okay? Indoor is obviously inside, in buildings, okay? We create buildings, so everything indoor is going to be anthropogenic, okay? We've made buildings. And this is going to affecting in buildings, and it's affecting people and pets. Okay, that's really the only living beings that live in buildings, are people and pets. So that's who indoor radiation affects. And examples of indoor radiation. Radon. Radon is a gas that leaks out of the ground, and it goes right into a basement and just sits there because it's super dense, so it stays in low places. So it leaks out of the ground, and inside there's no breeze to blow it away, so it just kind of collects inside your basement, and it can cause cancer. VOCs, which would be like paint fumes. Okay, so volatile organic compounds. If you spilled gasoline or kerosene, if you open paint, when you smell that, those fumes, anything with fumes is going to be volatile organic compounds, VOCs. Okay, smoke. If somebody in your family smokes, then you've probably experienced the cigarette air pollution inside a building. Okay, carbon monoxide. When you have a gas-fired furnace or a gas stove, carbon monoxide is a byproduct of burning things. And so carbon monoxide can collect inside a house if something's going wrong in the burning and we're creating too much carbon monoxide instead of carbon dioxide. Okay, asbestos. Asbestos is a material that we've used in buildings to insulate the buildings. It's great insulation, but now we know that it's pretty toxic. It can cause cancer. And so when we tear down a building or we renovate a room in a building, if there's asbestos there, the dust particles from that asbestos get everywhere, and that can cause a lot of problems. That's an indoor air pollutant. And then like dander. Dander is an indoor air pollutant. Dust. The dead skin cells is what dander is, right? So that's creating most of the dust in your household, and that is something that if you were outside, you wouldn't really get a lot of dust unless you're in a dry place and it's a super windy day and you've got a lot of dust blowing up off of the ground. But dust is a much bigger pollutant indoors. Okay, so those are some indoor and outdoor examples. Okay, primary versus secondary. These might be new vocabulary words for you. So primary means released directly into the air. Released directly into the air. And this is going to be most air pollutants. So when an animal farts, that's just a methane released into the air. Okay, when a car gives off exhaust, that's released directly into the air. It's already a pollutant. Okay. Secondary is the one that we have to think a little bit more about to understand. Secondary is something that is formed by a chemical reaction in the air. And that chemical reaction, it's a reaction with sunlight or water, okay? The examples of secondary air pollutants that we are going to talk about are ozone and acids. That's it. So if there's sulfuric acid in the air, it's because a factory or a car gave off some sulfur oxide compound that reacted with water and it made an acid in the air. And we'll learn more about that. If it's ozone, that is something that ultraviolet light can cause chemical reactions with molecules in the atmosphere, and that creates ozone. Or lightning. Lightning has enough energy to create ozone in the atmosphere. Okay, and so those are things that can be created after the fact in the atmosphere that are also air pollutants. Okay, all right, then the final little topic I want to go through here is potential problems with air pollution. So some of these are going to be really obvious and some of them not so much. So cancer, that's one, okay? Indoor air pollutants that don't get filtered out can lead to cancer. And I'm going to give you specific air pollutants, radon and smoke, okay? Yeah, radon and smoke. Now, I guess speaking of smoke, we had a lot of smoke as an outdoor air pollutant as well. So smoke can go indoor, outdoor. Normally that's an indoor air pollutant, but when you have massive amounts of forest fires, that's going to be an outdoor pollutant as well. Okay, but anyway, radon and smoke can both cause cancer. Okay, other health hazards. So you might not think about other health hazards that could be associated with air pollution. So asthma, did I spell that right? Yep, asthma and other lung problems. Okay, there's lots of different lung conditions that you can have, okay, can come from both, whoops, indoor and outdoor air pollution. Okay, fortunately, we live in a place that has very high air quality most of the time. Again, forest fires kind of make it a little bit poorer, but we live in a place that most of the time has very high air quality. So we're really lucky with that. Some people live in places that have very, very poor air quality because they're next to a big city or a high factory production area, and they're breathing in those chemicals all the time, even when they're outside, and that can cause a lot of lung problems. Okay, acid rain is one, and this damages plants, soil, and buildings. And acid rain happens when, again, those secondary chemical reactions happen and form those pollutants after the fact. And then the rain falls down on things and degrades those things. And then I'm going to put climate change here. Quick changes in weather patterns could potentially affect ocean levels, right? If melting ice caps happen too fast or all the way, whether it's fast or not, our ocean levels are going to rise, okay? Amount of hurricanes and tornadoes, okay? We're seeing a lot more of those weather patterns because of the rapidly changing climate, and migration of plants and animals. Okay, now you might think, wait, what, plants migrate? Well, as temperatures rise across the planet, there's plants that can't handle that heat, and they have to migrate by spreading their seeds further upslope where it's cooler. And if that doesn't happen fast enough, those plants just stop existing. Okay, so migration of plants and animals are affected by climate change. Okay, forest fires, frequency of forest fires is another really good one that we've experienced here. Okay, frequency of forest fires. So as the climate warms with more CO2 and more methane in the atmosphere, our climate is starting to warm. And those are some things that are happening as a result. Okay, so those are the potential problems. That's our air pollution notes. We're going to get more on specific air pollutants later, but thanks for tuning in, and I will see you in class. Make sure that you reach out if you have any questions, okay?